Example 4. Write cosine of arc sine square root of 3 over 2 plus arc cos x as an algebraic expression of x that does not involve trigonometric functions. All right, so let's get started here. First, what I want to do is point out that cosine, and then I have two angles adding. We need to go to our formula and realize that cosine with two angles adding is like cos A times cos B minus sine A sine B. So that's the formula we'll be using here, and so I'll write it that cos of A plus B is the same thing as cos A cos, oops, got the cos B minus, because cosine changes, symbol changes, sine A sine B. Now, before we get going, what is angle A? This is our angle A. This is our B. And so this now says arc sine of square root of 3 over 2. Now remember, with inverse trigonometric functions, you go from the quickest way to get both a positive and a negative. So for sine's purpose, since sine is a y value, the quickest way to get either a positive or a negative would be in these two quadrants here. So it's either going to be the first quadrant value or the fourth quadrant value. Since it is positive, we're talking about in the first quadrant. Where would sine be square root of 3 over 2? So since this is inverse, we're going to start with our hand upside down, backwards, if you will. So I'm looking at the back of my hand right now. And sine is y, so I need to have 3 fingers. So if I count 3 from the top, so pinky, ring finger, middle finger, I would bend my index finger, which is my pointer finger. I'm bending that finger. Now when I flip it over, I would ask myself, which finger is that? So if I'm bending my index finger and I flip it over, that index finger represents 60 degrees. So this right here would be square root of 3 over 2 for the y, like angle A is. And so I put an A there so you get mixed up. And that comes from 60 degrees. So here, we now know that A is 60 degrees. Do an arrow. That means A equals 60 degrees. So this here is 60, and this is 60 degrees. Well, cosine of 60 degrees, so while I still have that index finger bent, I'll flip it back in. And so looking at the back of my hand, cosine would be, I have one finger there. So this value is the square root of 1 over our h, which is always 2. And over here, the sine, which we already have, we said that that is the square root of 3 over 2. Okay, now let's find cosine B. This just says x. Now, if it's just x, then our cosine is x over 1 like this. All right, so now to find this angle, what I'm going to do here is draw a triangle. And x is obviously our x-axis. That was supposed to be a straight line. That's terrible. There we go. That's our h. So this is going to be x. This I'm going to say is h. Or the y. H is 1. So it's like a unit circle. And to find our y, we would use Pythagorean theorem. So I'll say that y equals. You go from there. Okay, so if I'm going to do Pythagorean theorem here to get my y, let's say that x squared plus the unknown y squared will equal 1 squared. And to get y by itself, I would say that y squared equals 1, because 1 squared is 1, minus x squared. And now, when I take a square root, this would become, typically, we'd say plus or minus here. Square root of 1 over 1 minus x squared. But I'm not going to actually do this as if it were plus or minus, just because it's an unknown value and we don't know which way it works anyway, so I'm just going to leave this as just the positive and go on from there. So that's what, oops, this is what we're going to say y equals. So I'll just leave it like that, except it won't work for me going like that. So I'm just going to make this way like that. Okay, so y is going to equal the square root of 1 minus x squared. So that's our value there. So now, when it comes time to finding cos here, when it says angle B, we just discovered we have this relationship. And so if I want cosine of B, this is for triangle B here, comes from this. cosine b would be x over 1, which is simply the x. So this would be times this here is x over 1, because it's x over 1, which is simply x. And then over here, I put the minus. Sine b would be y square root of 1 minus x squared over 1 as well. And so we'll multiply these to simplify. This is just square, that's 1 times x is x over 2 minus, over here this is also over 2. The square root of 3 times this would be square root of 3 minus 3x squared. And so to get my final answer, I would put these together because since it's a common denominator, and I would say that this equals x minus square root 3 minus 3x squared all over 2. This here would be my answer. And I wish there was a way I could type it in the calculator to check, but there is not any way to do that other than making up a number for x and checking it. And so if I wanted to make up a number, sure I could. I could check it like with, say, x is 15. Now it would have to be a length. X would have to be something less than 1. And so if you just tried like 0.75 and put 0.75 there, it should work. But that's the best we can do is checking is just making up a value. All right, now let's try example B. So we have similarly the very kind of same thing going on. We have sine of two angles here, and they're subtracting. So if I want to go to the formula chart, sine subtracting. So here's sine subtracting. The sine stays the same, symbol stays the same in sine, but it goes sine A, cos B, cos A, sine B. So it's going to go, let's go back over here. What we have here is it's going to be sine, this is A, this is B. And so I'm going to draw little triangles to figure this out first. So sine is y over h. So we'll put this over 1. And this is, so we'll say for this triangle A, do it over here. Triangle A. What do we have? Is we're going to have that h is 1. And that our y is 3x. And so to find the x, what does x actually equal? This is our y. Y equals 3x. What we would do is the Pythagorean theorem. And so we would have that x squared plus the y squared, which is 3x squared, equals h squared, which is 1. To get x squared by itself, I'm going to move this over here. So x squared would equal 1 minus, this becomes 9x squared. And then you take the square root. And so here, over here for my x, when I write that, it's going to be the square root of 1 minus 9x squared, like that. And that's what we got here. Now what's a little different is this x is different from this x. This x is just referring to the x value here, the x length. This x is some value it's used over there. And now for triangle B, I'm going to do basically the same thing I just did. This time it's saying the cosine is x, which means if I put this over 1, that's my h right there. So this time when I draw this triangle, same concept as before. We have an h of 1. And we know that x is just simply x. What we don't know is y. And so to solve for y, we do Pythagorean theorem. We would say that x squared plus y squared equals 1 squared. Again, I'm going to subtract that over. So I'm looking for y. So I'd have a y squared equals 1 minus x squared, because I subtracted the x squared over. And to get rid of this square here, I would take the square root. So I'd have y equals square root 1 minus x squared. That's this length here. So y would equal square root of 1 minus x squared. Okay, after doing all of that, we have that sine of a plus b equals, this is from the formula chart, sine a cos b. Symbol stays the same. Oh, wait, this is supposed to be minus here. Minus a minus b minus cos a sine b. Okay, and so we go to plug these in. So to put all this together, I don't know what just happened here. Minus that right there equals. Okay, now I got it lined up right. Sine a, that means of this a triangle, I would have sine, which is 3x over 1, times cosine of b, so it's x over h, which is x over 1, minus, I'll do that in black so we don't get mixed up, minus cosine of a, so over here, cosine is x over h, times sine of b, times this square root here. Oops, let's do it red here, times, that's y over h, square root of 1 minus x squared all over 1. If you wanted to reduce this, you would have 3x squared minus these two square roots multiplying. Well, technically, we'd have to FOIL these all out. And so you'd have 1 times 1, which is 1, 1 times negative x squared, negative 9x squared times 1, negative 9x squared, and then negative 9x squared times negative be a positive 9x to the 4th power. That's a lot in there. And so finally, one more reduction here. I can say 3x squared minus, and I'll kind of combine my like terms here, 1 minus 10x squared plus 9x to the 4th. That is a whole lot going on right in that problem, but this would be it right here.